computer math of any kind. Computer, again, works with zeros and ones. So for whatever reason, we start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Computer doesn't work that way. We're working with a computer, instead of thinking 1 to 10, you've got to think 0 to 9. Everything starts in a 0. So the minute you transfer to computer math, if that is 256, you've got to lock one number off of it. So you find the highest number here is 255, which is 256 to you. Which is computer 255. So you've got that little quirk that you've got to keep in the back of your mind, or things ain't going to work all the time. Okay? So we've got run forward at what speed? So we can go up to 255 or down to 255. Now in motors, the way it works, a motor is a 1 or a 0, or it's on or it's off, or it's plus or it's minus. So if you want a motor to run forward, you say I want you to go forward plus 10. If I want you to go backwards, I want you to go minus 10, and I go backwards. So it's just another quirk of computers running motors as compared with your car. Okay? So just remember, you reverse the polarity in electricity, and now you've got a minus, or you went from a 1 to a 0, whatever way you want to work it in your mind. But if you want it to go backwards, you change a plus 1 to a minus. So a minus. So anyway, we want it to go forward, and we want to win the race, right? Right?
Yes.
We don't want to be second best. So we want to go as fast as we'll go. There's problems with that. Okay? If this thing hits the wall, you may break it. Right? If it hits the guy next to him, you may break yours. So, just like your car, very few of us want to drive our car at 120 miles an hour. Right? So even if you want to race, you do have to take into account, am I going around a corner? How steep is that? All roads will say, slow down. This is an exit. Slow down. Anyway, let's see what they want us to do next. Play a tone on note 6. So I find play tone on note, here it is here. And again, you'll see it snap too. It's going to go up there and it'll go right into there. So it's snapped in. Now we got a problem. Okay? We want it to play a tone. But we got to tell it what tone. Jack, what do we want it to play?
C6.
Okay, now you have to know some music. So again, this is where my sister-in-law was here a couple of weeks ago, and for one of the classes, and she said, isn't there an easier way to do this? Well, yeah, there is, but not for the kids today, and not for the programmers. For those of us who just want to flip around what we call user-friendly, intuitive. But if you want to get into programming the man to go to Mars or live there, the oxygen tank and the phone, there's no easier way to do it. So now you have to learn some music. The musical world goes from 8 octaves, 88 keys. C1, C2, C3, C4, C5, C6, C8. They're octaves. Okay? Each of them has something to do with physics. C is middle C is C4. The A above middle C is A4, and that's the standard that all musicians must tune against. So if you have a tuner, you've got to make sure it's tuned to A equals 440, which is a sine wave 440 times, and it's C4. So same thing here. The computer's going to say, well, tell me what you want me to play. I don't know what to play. So I want you to play A4. And I know as an engineer, A4 is 440 sine waves. Okay? A3 is half of 440, 220. A5 is double that, 4/4 is 880. So, anyway, Okay, so we want it to go very fast, and we want it to play. Well, here it tells you what it will play. And let's see if we can go down. There's a G4. Well, I guess it won't play it. So let's say a G4. G4 is right next to A4. Okay? So anyway, any questions on that? Can you follow what it's saying here? Now, this is where what you do. Each of these blocks is a lot of stuff. So if you're doing a text programming, the way my daughter got her degree in computer science here at ATU, most of you probably never remember ATU. It was here back in the 80s, Advanced Technology University. She got her degree in COBOL, Fortran, and assembly language. I don't even think they use those two languages anymore. But anyway, this is a lot of text. So if you look at the other side, that's the nice thing about this, is that not only can the kids learn all this stuff I'm telling you, how to make that robot go fast and slow, turn right, turn left, follow a line, follow a red line, follow a green line, whatever. Okay, how to beat, tone, or how to play music, as that fact. And the beat, how fast you want it to go. If you want 10 beats a minute, if you want to dance a polka, use it as a metronome, 220 beats a minute. Just click up here and tell it how fast, what kind of notes you want, and so on. This is how MIDI music is done. I use a lot of MIDI music and I teach it. I met hardly anybody in Killeen I can talk to about MIDI music. It's been out since 1986. A few years ago, the only one I met was Jeff Smith at Ellison High School Band. He was very competent in it. So there are probably more, but they tend to, very few that use it. So both of the girls I mentored, both of them were very qualified in it. Anyway, if you look up here now, on the other side is what you would have to put in if you were typing the code. You would have to type this in, just like you type in something. So it's got what? It's got a pound sign, and it says include. So now you've got to tell it what you want it to include. And these are programs that somebody else has done that's setting off on a shelf that you've got to pull off of the shelf into your program. So that block tells it to include the Arduino.h, which is C+ language, include wire.h, include servo, which is a motor. There's three kinds of motors: servo motors, stepper motors, and brush motors. So you're telling it, I want to include a servo motor.
Where are you right now?
Pardon?
Where are you on the schematic?
Okay, over on this side.
Oh, yeah.
We were here.
Yeah.
And that's what I have on screen, but this is what that is.
Okay.
But that's the way you do the programming. And then I gotta tell it a lot more. It's like baking a cake. You gotta get the pan out, you gotta get all the spoons out, the strainer, you gotta get everything on the table, okay? You want it to include the Mbot H. You want it to include me port. That's their particular way of getting information into the Mbot. You want to include the me buzzer. You want it to include the me, that's their company name, Mbot. That means they've written this program. Rgb, you want it to know what R is in green, red and green and blue is. Include the DC motor. You want it to include the DC motor also. Then you get done. No, that's all just setup. That's just telling you this program, or this computer, get all this stuff on the table. You're going to use it very quick. Okay? So, and down here, then if you go into voice setup, it tells the computer what to do. Okay? While you have, anybody here familiar with Boolean algebra or logic.
I
No.
couldn't explain it, but I've heard it talked about.
Well, we all learned it, but we learned it probably easier techniques in learning. So it's if, what, neither, nor, and,
Okay.
one and two, okay? One plus two part. One and two, not four. So it's neither, nor, and, or, if, but, so on. So these are called in Boolean logic or algebra. These are in the computer world too. So, and that, for example, remember when we said this triangle says go back? That would be one of these logics to say we did either and. Now we're getting to a if or while statement or nor. We're not up to 10, therefore we're not going to win the race. So go back and reset me. So that's what Boolean logic is. And then if you go down there, there's another while loop, and it says the last time equals milliseconds. You see that? It's not on the screen yet, down here. Last time milliseconds, count equals 1. So this is where we just set the counter, remember? We had to set the counter with one of these blocks to 0 or to 1, whatever you want. So here's going to set it to 1. Also, you have to have what is called a delay. Okay? Delay says, wait, don't do something. So you don't want sometimes two things conflicting together. So you say, I want you to do this, like turn on a light. I want you to turn on this light for 1 second and then wait 10 seconds, just like a stop, the red, green, and yellow stoplights. And they use these to teach kids how to program too. You turn on the red light for what? Anybody? If you're in your car? Anybody? If you're in your car driving, you come to the stoplight. How long do you want the red light on?
Until it goes off.
2 seconds, right? But it ain't 2 seconds.
No.
It's gonna be more like 30 seconds. It feels like eternity. So then you want the yellow light on for maybe 15 seconds, because all it's gonna tell you is you're gonna get a ticket if you don't do what I say, right? And then the green light you might want on for 30, 40 seconds or 2 minutes. And then they changed that by radio waves. Now they're mostly solar controlled, and then they'll send out a radio wave signal that will change them, like down here, when you're traveling down Stan Slater at 5 o'clock, maybe a lot different than at midnight tonight. So they'll change, all they do is change these little quicks there. They change the seconds. Okay. And then if you go down to the next while loop, it'll say motor move 1, 100. Delay 1000. That's the other thing you've got to realize when you're working with computers. Computers actually work some of them work in nanoseconds now. This is where we get down into this real finite world and so on. So, but computer works in milliseconds. Okay? So you don't put 1 second, you put 1,000 milliseconds. So if you want 10 seconds, it's 10,000. Here's the number you put in. So if you're going to do computer programming, you do have to do the way the computer works and not the way you work. Yeah, Jack?
Well, where it says 1,000, I would assume that means
The last
times
one.
3.
The last while loop. You see it there? Motor move.
Okay.
Then it says delay 1,000 times the count. So that means 1 second times whatever counter you put in. If you put 10 seconds in, that'll be 10 seconds times 1 second, or 1,000 times 2. 1,000 milliseconds times 2 would be 2 seconds.
What does the Rgb Led mean?
The what?
Rgb Led, what's that?
Where's that?
Well, it's in several places.
Okay. Roy, tell them what. Somebody should know that when they're coming to class. RGB we talked about here, red, green, blue.
Okay,
LED is what?
lights.
A light.
Okay,
So
okay.
that's gonna control
The,
the light. And there you've got there the colors we talked about. Right under that, it says 7, and that will be the pin number that you're gonna put the wire in on this device, the computer. There's pins that you put wires on and solder them and so on. So, and then the color is gonna be whatever color you put in. There they got 000. And we went over color coding last month, I guess it was, yeah. And the color coding, and this is where the color coding comes in. Let me just go over that quick. For the new ones, this is the easiest way, I think, to learn, okay? So I use a lot of graphics in my learning concepts. It really helped me. The other thing that I learned is what we call mnemonics. Kids are not, generally speaking, learning a lot of these, what we call learning techniques or memory techniques. When I got out of the Army and went to Austin Canada School, they sent me to a remedial reading course. I didn't realize I didn't learn how to read. 12 years of school, and I didn't learn how to read what the Army wanted. Okay? They sent me to remedial math. And again, in just 9 months, they taught me things that I somehow missed in 12 years of school. But anyway, the circle concept is a